Okay, so for topic 3, we're going to be dealing with multi-step inequalities. So it's essentially the same steps we use to solve multi-step equations. For the first one here, it's negative 3x plus 12 is less than 18. So we're going to approach it the same way as equations, getting the variable by itself by subtracting 12 first. Okay. And we're left with negative 3x is less than 16, or the 6 rather. In this case, remember the rule we learned prior that says if you multiply or divide by a negative number, then you have to flip the sign. So we're going to be dividing by negative 3 here to get x is greater than negative 2. And we graph our answer the same way we have in the past. I put a negative 2 down here, do an open circle, and to the right. Okay, example 2. Be careful with distributive property here, so we're going to distribute the 3 into the y and the minus 4 before we do anything else. So we have 3y minus 12 less than or equal to negative 15. Add the 12 to both sides. So we get 3y is less than or equal to negative 3. And we're dividing by a positive 3, so no need to flip the sign or anything. We're going to have y is less than or equal to negative 1. So this is a closed circle pointing to the left. Okay, so you should pause the video and take a look at the U-tries below and try those two problems out. Okay, so now we need to look at two unique special cases for solving inequalities. Let's look at the first one. We're going to try to solve this one here. You might already notice that we have negative 3x on both sides here, but the numbers are different. We have a 5 and a 17. So if we try to do this like we've done in the past and get all the variables on one side or the other, we could try adding 3x to both sides. In doing so, we cancel the 3's here and here. So what we're really left with is 5 is less than 17. Well, that is technically true in that sense, but let's see here. So as you can see here, we have 5 is less than 17. So there's no more variables or anything like that. So the inequality that's remaining is true all the time. So that's actually considered to be all real solutions. You can also write it like this. It's like a fancy looking capital R. And the way we're going to graph that, since it's technically all answers, we can just put like an arrowhead line going both ways, covering all our bases. Now, I started solving the one on the right here. So we're distributing the 2 and looking at what we have left over here, we could subtract out the 2x's on both sides. And what we would get is negative 10 is greater than 9, which is not true. So the inequality would be false in this case. So if it's false, we consider that to never be true, it's never going to work, so it's no solution. And we have this little null set symbol, it's basically a circle with a line through it, to also write it in shorthand notation. And in terms of drawing that on the number line, since there are no answers, we would just leave it blank. So there's none of those for you to practice in the notes, but we'll be practicing those in class.